Ford T in 3D. We will compare the engine with a modern one to see what changed and what happened to the reliability of new cars. The engine is a 4-cylinder of 2.9-liter or 177 cubic inch. As a first observation, we can notice that the crankshaft has a large radius and the connecting rods are very long. This is due to several reasons. In 1908, Henry Ford believed that an engine was more efficient when a longer stroke is applied. In this way, the torque could be easily increased. On the downside, because the parts were heavier, the maximum RPM it could reach at was much lower, being only 1,800, which resulted in less final power. However, the low number of revolutions gave it a very good fuel consumption, being 13 miles per gallon. A modern engine runs an average of 33 miles per gallon. Yes, it's more, but considering that the fuel of 100 years ago was 40 octane, unrefined, without special additives, 13 miles per gallon of the Ford T was really good. Engine compression was just 4.5 to 1. Only the half compared to today's car. This low compression allowed the Ford T to run on kerosene or alcohol. The low compression also made it easy to crank the engine. It was not until 1919 that the electric starter was introduced as an option. We don't have to forget that the engine was fed by a poor carburetor with some manual adjustments. Another advantage that the Ford T had compared to modern cars is actually its lack of parts. There was no fuel pump. The tank was elevated and it flowed by gravity. It also did not have a filter. A small bladder was used where the sediments fell, and then a valve was opened to remove them. It is true that some fuel was lost in the process, but it should also be noted that it was not necessary to look for a new filter every time. Another part that did not have is the water pump. Actually, this unit was only used in the first year and then permanently retired. In this way, problems with seals, breakage, etc. are avoided. The water moved naturally by gravity. We all know that hot water goes up and cold water goes down. This generates a natural circulation of water. The refrigerant circuit was not pressurized. Every some time you had to fill it with water due to evaporation losses, but this also prevented a water hose from bursting due to high pressure, which in a certain way increases reliability. Another item missing from the engine was the oil pump. When there is no oil pump, means it can't fail either, so reliability goes up another point. The lubrication system was primitive. Every time the crankshaft went through the bottom, it hit the oil level, splattering it everywhere. The oil was the same as that of the gearbox, which with the use of spoons also made the same job and raised the oil towards the engine side. Another advantage of using a long connecting rods is that reduces the angle of inclination, the friction and pitch of the piston decreases, and the amount of oil required in this area is much less. The wear also goes down and slightly raises the power. With less friction, the temperature is also lower. Of course, this method of lubrication does not allow high revolutions and also generates foam in the oil. Something bad, because the foam does not lubricate and is also a thermal insulator. In a few words, it can be said that the only accessory that the engine had was a dirty woven leather belt that only moved the fan. The camshaft is not belt-driven. This work is for the ultra-reliable gears, totally eliminating another reason for failure caused by the belt when it dies. The block is made of vanadium steel, an advanced alloy for the time that gave it toughness and resistance, reducing the formation of possible cracks. The valves are not in the head, they are inverted and in the block, guaranteeing there is no interference between piston and valve. The cylinder head is removable to allow repairs if necessary, and it is a flathead type. It only contains the spark plugs. However, while this type of head is very inexpensive and reliable, it reduces efficiency drastically compared to a modern car. Although for the Ford T, which rotates at only 1,800 RPM, the losses are low. Another great detail that we cannot omit is that the crankshaft only has 3 bearings instead of 5, as in a modern car. The lower number of bearings increases the crankshaft requirement due to the lack of supports. Although considering that each cylinder only produces 5 horsepower, this amount is consistent and eliminates unnecessary friction surfaces. Finally, we will go to the ignition or spark system. There is no high voltage distributor. The job is done by a box with 4 individual multi-spark coils called trembler coils. These coils are driven by a low voltage commutator or distributor, making it more expensive but also more reliable and ensuring that anything that enters the cylinder will be burned. The multi-spark system means that if the first spark fails to ignite the mixture, the next one will, reducing misfires to a minimum. The plugs and wires were simple and did not have any anti-noise technology as is it necessary today for the computer to work.